So we'll start the program. Quickly, we'll have an introduction of myself. Be in plastic technology, thermoplastics and thermoset plastic technology for 20 years now. And been taking trainings in multiple OEMs. And I have hands-on experience in mold design, product design, mold making, rheology, mold flow, plastic raw materials, application development, injection molding process, molding machine also, mold trials, troubleshooting, and SOPs and setting up the systems. And recently, 5 to 6 years, I have been offering training in many OEMs in India and tooling companies also. And I worked with Supermax, the razor manufacturing company, then Technic, Larsen and Toubro, then Schneider Electric, Sabix as the All India Technical for Specialty Portfolio, and GM Modular. And I've been associated as a trainer at Mahindra & Mahindra, IMTMA, and Tyrma also. This is 100 Technologies, my B2B marketing consultancy, which is into plastics. And I'm a business partner, development partner for Uniclean Plus Purging Compound. And this is my startup is into the with the vision of accelerating Indian tooling industry instead of injection molding. Currently, we provide offline training at the customer place. Later on, we'll be adding some more thing. You'll be knowing it shortly. And we are implementation partner for EcoAxis, the AT group, where it is IoT-based system tracking of molding shops for molding machines. All these things, even from the power, the OEs, all these things can be tracked. Okay. Actually, I started the training with a vision. I used to travel a lot in the industry, attending the problems, and we'll be seeing that the problems are keeping on repeating the same customer, multiple customer also the same problem. So how can one person going and attending? It's not possible. From that, I started. I became a trainer for that reason. And my vision is to advance Indian and plastic industry, molding and tooling industry. And currently we are struggling to qualify. We are struggling to export critical parts. When we talk about fit and function part, yes. But when we talk about critical parts, which needs repeatability or very close tolerance, still, India is not an option for the globe. So my intention is to bring that capability in India. So currently, solutions, we take technical training in companies. Second, Uniclean Plus Purging Compound, we supply. And IoT driven EcoAxis, and the lean implementation. Government of India, our organization is a lean implementation partner for Q's Quality Council of India under the Government of India initiative of MSIL, MCSL. Welcome one and all to this program. Okay, let us dive into the program directly. So I start with this statement, what I've been observing in the industry. Around 80% of molds faces challenge in predictability in timelines from the T0, the first trial, to its final qualification. Maybe sometimes we have a very good control, if you see in India, a good control on T0 first trials, but later on, the qualification, the dimension correction, all these things, the industry is struggling. That is a challenge I've been observing. It is not because we don't have accurate machines. We have very good buying machines and very good make-of machines, all the global standard machines we Indian tooling industry has. And it is not because we don't have a good molding machines also. The machining center is there, good molding machines are there. And we have very good potential market also. Okay, the market is demanding and huge. There is a huge opportunity nowadays. Okay, picking up in different segments, including critical parts, mobile phone, electronics, everything is picking up. And it's not due to unavailability of good standard, or we also have sufficient standard of steels and standard mold base, standard mold elements also available in India, which is required for our condition. And it's not because we don't have access to any of the technology. We have good technology machines. Is the technologies are the we have access to rheology platforms, okay, raw materials, everything is there. Then still, why we are struggling? And what is the real challenge? No, this is as per my observation and been seeing, and the basic challenges what we are facing. There are a lot of new applications which are coming up nowadays, and instead of commodity plastics, nowadays the arena of specialty plastic, higher end plastics, polymers with tight tolerance, which require a tight tolerance pattern, or extended life, more life expectation as more. This is one of the challenges. Everybody is, I openly tell, everybody is focusing on cosmetics, how the part looks, rather than that, and the cosmetic is achieved by adjusting the molding process. The molding process does not have any window, and we keep on adjusting the molding process. The molder is so much dependent to get a good part. There is a huge skill gap. Mold making industries become like an experiential. It's like we tell it's a real science, but the science has become like an art, and the science and calculation really overlooked many of the cases. Industries and the industry is lacking somewhere related knowledge of depth of polymers and lack of concurrent engineering, because interdepartment, some design department may have some knowledge, and molding people have some knowledge, tooling people have some, product design has some knowledge, and mold flow people have some knowledge. We are not converging, and interdepartment concurrency is not happening because there is some gap in the knowledge. The one person's language, the other person or the department is not able to really understand. That's what that's the thing I observed, and for this reason, I started to research training and started making. And now we directly go to what is the real expectation from an injection mold or a molding or whatever it is. Okay, for any manufacturing, if you consider. So real expectation is the consistency. If I tell the consistency means whether whatever today I produce, tomorrow if I produce from the same mold, it should have the same in terms of dimension. Consistency can be dimension, cosmetics, how it looks like, performance, and everything, and can be overall quality, mechanical property, the thermal property, the electrical property, whatever I am producing now, it should be repeatable, it should be consistent. So the consistency is a real expectation. We may have some people have I wish to know about molding, I wish to know about product design, but the industrial requirement or the real expectation of the whole industry is getting a part repeatability, so that our life will be easy. Okay, we can run the part very easily. So that's how this can be achieved as a question mark, but this is the real expectation of the industry. See, when I talk about consistency, there are 3 levels of consistency if we consider a mold as far as a mold is concerned. The molding is concerned. First level of consistency is a cavity to cavity consistency. Courtesy to Suhas Kulkarni, FilmTech, I've taken this from his teachings. So first level of consistency is cavity to cavity. If we have a multi-cavity mold, suppose 2 cavity or 4, here I've shown an 8 cavity mold. All the cavities in the mold should behave the same way. If one cavity is not behaving the same way, one cavity is getting different dimension, other is getting different dimension. Even we are modifying the process parameter also, will not be getting the result in. So the uniformity of all the cavity is the first level of consistency. All the cavity behaves the same way. Any process peaking, any change we have done in the process, all the cavity will reflect in the same way. Be it will be dimension, be it will be fitting pattern, filling pattern, be it will be term of cosmetics, how it would look, and mechanical performance, overall quality, all should be the same. This is the first level of consistency. The second level of consistency is known as shot to shot consistency. It means first shot to second shot to 10 shot, 10 shot to 50th shot, 50th shot to 100th shot. So all the shots coming from the mold, first all the cavity is the same. But if suppose we have been seeing like morning the part is coming good, and after some time there will be some issues or some catching or some dimension deviation, warpage is coming, all the things are coming. So The second level of consistency, that is shot to shot. All the shot also should behave in the same way. Okay, consistent and repeatable. Third level of consistency is run to run consistency. It means today I ran a mold or I ran the mold for 2 days. My production is done. I downed the mold. I used another mold in the same machine. And after 1 month or 6 months, again I up the previous mold I started. Sometimes we have been seeing that we are not able to. People have been saying, look, last time it was coming good, and with this, no, it is not coming good. What has happened surprisingly? So the third level of consistency is run to run. Whenever you run the mold, if after a break or whenever you run, even after 1 year or 2 years, the mold should perform in the same way, and the part should have all the consistency in terms of dimension, maybe cosmetics, it may be overall property, mechanical property, overall quality, whatever is. So if we are able to make a mold or a process like that, all this consistency had been met, then we will be in a safe condition. Our life will be very easy. The toolmaker and the molder life will be easy. Even a problem comes, suppose a problem is coming, that also should be repeatable. It's not like something problem is coming tomorrow, it is getting vanished. So the thing is that repeatability is the core of manufacturing process. So this is what the consistency, the third level of consistency, what the real industry has to go for, and that is the real expectation. Now I'll talk about some of the variation. So is it so easy to meet all this consistency? No. You people are already from manufacturing, you'll be knowing it's not an easy thing. Plastic molding, plastics are really tough metal. One, if you think about, there are a lot of properties or a lot of things come together and give the quality of the part or a repeatability of consistency. Even though our mold is good, the machine is fantastic, we have all the accelerably everything right. Still, there are some factors we maybe overlooked or we are not thinking about that are not a natural variation that result in the polymer flow behavior itself. There will be some viscosity change or flow behavior change. These things are out of our control, really speaking. Whatever best of the machine we keep, still these are out of our control. One could be polymer MFI variation. If the molding metal that we are molding, suppose is the 10 MFI grade, means its viscosity. MFI is related to the viscosity or the thickness of polymer. It is the data sheet, it's showing the typical value 10 MFI. It will not be, all the lots will not be 10 MFI. There will be a variation. So where the polymer is coming from? The polymer is coming from huge value chain, the crude oil, then from the crude, like petrol comes, diesel comes, kerosene comes. Like building blocks of the polymer, also naphtha, ethylene, all this come from petrochemical. Then it is polymerized, monomers are made, then polymerization, and then compounding is done. So huge value chain. It's like I tell what is the color of a ripened mango. Simple example. You may tell it's orange color, yellow color, but whether all the mangoes will be the same color, if you check the LAB value, color value, no. There will be whatever comes from the nature has an inborn variation. But if I tell you the ice cream made of that different color mangoes, whether the customer accepts the variation, no, it will not be accepted. The similar way, there are a lot of variation comes whatever is coming in the nature, the raw material also. But the end product, there should not be any variation. That is the same exactly what the condition in molding people or tooling people are in. Okay. And not only polymer variations, environmental factors. The morning there is a different temperature, noon is a different, evening is a different, winter, summer. Every time there is a variation in the environmental factor, and the mold and the machine, everything is in that environment, and it is can be these factor also interferes with the consistency. So these are the factors which are really out of our control, which our control, whatever is there, we may be able to do, but there are a lot of things out of our control. And for even though a lot of things are out of our natural variation there, but can we produce a part which gives a consistency? Even the raw material change, the part, even the atmosphere or the conditions still can we produce a part which gives a repeatability? The mold gives a repeatability. So for this reason, the scientific injection molding is the real saver. And scientific injection molding, also known as decoupled injection molding. So how the decoupled name is, so when we are injecting a part, okay, when we inject the metal, molten metal inject to the mold, there are two phases. One is injection, second is holding phase. When we separate this both, when we think this injection separate and holding separate, that is known as decoupling or decoupled injection molding. Ideally, it's tell that 95 to 98% of the filling of the parts, okay, should be done by injection. Rest 2% to compensate the shrinkage or volumetric shrinkage should be done by holding or packing. Okay. So this is the process which natural variation will not affect the part consistency. Even though natural variation, it will not affect the consistency, we are saved. The process that respects the polymer inherent behavior. We may be thinking, low, the tool is like this, the machine is like this, tool has been done. But the basic polymer property never changes. If we are able to capture that right, then you'll be able to do. So here we'll be respecting the real property of the polymer to get a consistency. The process in which results are complete, I'll repeat this, results are completely depend on the creator, the mold, the designer, and the qualification. Here the results are not depend on molding or setting. Molding, setting will be very easy actually if you are able to take care. See, the real result, if you want scientific injection molding has to answer, then the things has to come from mold. And we have to check some of the things when the molding is done. Very less things. We don't be a master operating injection molding machine. We have to take 2 or 3 parameters, that's all. Looking at that, we'll be able to understand the way the mold will give a repeatability or not. So the 95% of the quality lies in the mold designer. Okay. And just 5% setting will lies within the molder. Okay, it will be very easy process. And I call it actually the name has been called like scientific injection molding. Instead of really honestly speaking, should have been called the science. It's a real science of injection molding. There is nothing best than that. So if you remove all the unnecessary things from the molding things, if you put some calculations and regarding the raw material behavior and all, then whatever is left back is scientific injection molding. And it's nothing something rocket science or whatever new thing came into market. Sometimes it happens like people are what is the new in scientific injection molding compared to the old molding process? So there is nothing new. It's the science of injection molding, and the science remains the same. Earlier 50 years back also, how the polymer behaves, only polymers have gotten added, new polymers. We have to take care of that. Okay, and the science of basic property of polymer keeps remain the same. So it's a science of injection molding. One should know, everybody in a show should know if you want to think about consistency or not just making a part that looking good only. Okay, repeatable. So to talk or to know about scientific injection before, it's very important to know one of the polymer property, one of the property of any of the polymer or a fluid, known as Newtonian and non-Newtonian property. So what are Newtonian materials? See, I've shown some example like an oil or a water. The material or the fluid which viscosity remains the same in different temperatures. Suppose I'm passing water through a pipe, and the output is like 10 liters per minute, and the temperature of the water is 30 degree. I change it to 35 degree, 40 degree, or 50 degree. The amount of water coming, there will not be drastic change, there will not be change. That means the viscosity of the water will not change with respect to the temperature or the shear rate. If you rub your both hand together, okay, you can see there is a shear happening. No, it's not a shear. The molecular rubbing. It generates the heat. So the more the heat, viscosity should shift. But in case of water, Newtonian material viscosity, there will not be any change with respect to shear, which is correlated to the temperature. But in case of non-Newtonian material, it's not the case. Every degree temperature change, viscosity keeps on changing. For an example, if you are injecting an ABS or you are molding an ABS at 200 degrees, suppose, for an example, okay, if part is not filling, you will increase the temperature and fill the part, right? So how it is happening? It's because with the temperature rise, the viscosity, the shear rate is increasing. With the shear rate, the viscosity is dropping, and it is becoming more and more like fluid, like water is. Okay, so that is what those type of material which changes its viscosity with respect to shear temperature is known as Newtonian material. So where our polymer stand. That is my question. Okay, you can type where our whatever polymer we are doing, where it stands. Yeah, some people are telling, yeah, it's non-Newtonian. Yes, you are correct. By increasing the temperature, the viscosity is changing, so it's a non-Newtonian. Then my question is, then if you are operating with a polymer with every degree temperature, there is a change in the flow, there is a change in the viscosity, there is a change in filling pattern. Can you expect consistency? Shot to shot, run to run consistency? Can you expect the material which changes is always changes its character, it changes its flow behavior, changes its viscosity with every degree temperature? Can it be possible to get a consistency, or we have to forget about consistency in plastics? Then what is the trick? Okay, the beauty is that at certain shear rate, okay, generally if you see polymer acts as a non-Newtonian, with every shear changes, the viscosity keeps on changing, it becomes more and but the beauty of polymer is at certain shear rate, above certain shear rate, this polymer behave like a Newtonian. So the whole science of scientific injection molding is to understand where is the real Newtonian position of that material in that mold, with that gate, with that machine, with that injection speed. Where is the Newtonian area, and keep the injection speed in that and proceed with this. So that is the first step, which is known as viscosity study. So if we are operating in non-Newtonian metal, forget about consistency. We have to find out that sweet spot where our polymer becomes a Newtonian when we are injecting. Okay, so understand this is a very important factor for going for a consistency. So what is the advantage? I'll be going through those things. What are the steps? What is the advantage of scientific injection molding or SIM? Since I am operating in an area, Newtonian area, where my polymer viscosity will not change with respect to shear. No, there is an area. Since I am finding out my part will be super consistent, I'll get a very good improved consistency. And this is a data driven. This is not a hit and throw. No, some problem comes somehow I can then solve. No, this is a data driven. There is step by step procedure for qualifying mold. Very proper steps are there, and not just trial and error method. And this is robust. This is a very robust steps. Steps are very robust for qualifying and getting the repeatable QI, QPQ, whatever you tell. No, this is a very robust step we have. Okay. And it reduce defects. We will not get any surprising like in the mold is running suddenly. No. The consistency there, we will not get reduce so much reduction. The defects will be there, and obviously efficiency, you can the capex and your mold or machine utilization itself, and it's very efficient process. Cycle times in terms of, and you don't have to keep on tweaking the molding process. The process itself has its own control. No need of a person who is experienced always keep on adjusting the process parameter to make the part look good. I will tell look good. Okay, so that's not required at all. And this has very good predictable timelines. If we commit something, you know when it is going to finish, because the rejections are well under control. Obviously, there is no lower the part cost when we are going for scientific. You will get a better cycle time, better injection time. Lower the part cost and part performance, be mechanical, thermal, dimension wise, repeatability, chemical performance, whatever performance. The performance of part means whatever the material property is there, ideally the same property we are intending to get on the part. So if we are damaging the material in the machine, molding machine, we will not get the exact. We are damaging the molecular weight. This process respects those things. We are considering the raw material property and processing, and we are doing the mold also as per the raw material property, really speaking. Not just filling. Not just filling is the quality of the part. Filling can be done somehow, pressures and all. This is not by preserving the raw material property without having a stress in the molded part. So enhance very good performance of the part. Most performance can be received by doing SIM. And troubleshooting itself, root cause analysis itself is very easy. Otherwise, we have to know trial and error, keep on doing. Here, it will be very easy. Okay. These are some. So how to achieve consistency the scientific injection molding way. Okay, those were the advantages. But how we can do this? How the consistency can be achieved in this way? Okay. So the scientific injection molding is carried through 6-step study. There are 6 steps to that. Properly, we have to go through those steps while qualification of the mold. I repeat, while qualification of the mold. This is not something has been done wherever your productionized for years and year and you are going. No, it can be done. But if you want the result, I told the creator is the responsible at the time of creation of the mold. If you are able to take it, then I've been seeing that many people have the scientific injection molding worksheets or spreadsheet. It doesn't get answered. The thing is that if it has to answer, then the tooling, basically the feed system, the cooling. I can tell you the feed system is a very important criteria. Okay. So that has to be gone in depth. The 6-step study is known as scientific injection molding or decoupled molding study. First is the viscosity study. I'll be going just showing that. In viscosity study, we'll be identifying where is the Newtonian area for that mold, that runner with that part and what that mold, the combination of the raw materials. Second is gate cavity balancing, means whether my all the cavities are coming in the same way, cavity to cavity balancing. So that is the second study in the 6-step study. So we'll be seeing physically also, we are weighing also we'll be seeing. Third is a pressure drop study. Okay, pressure drop. Even the part is getting filled. If you are taking more pressure to fill the part, there is nothing great in that. Okay, we will not get a repeatability. Suppose a person is always in a pressure. It's a simple thing. We are in a continuous pressure. We'll not be able to give our 100% output. No, we'll get tired. So to get a consistency, the pressure drop, whatever pressure pressure drop happening in the feed system, like the screw, bush, runner, gate, and the part, should be within some limit. There are some thumb rules to that. If you are taking so much pressure and filling the part, forget about repeatability, consistency in terms of dimension, all these things. You can use it for fit and function part only, just fill. Okay. So this is the third one, and fourth is the cosmetic window. Okay, first 3 things is really the process setting, the optimization of injection, and all these things, and then comes the cosmetics. When the process is set, then we talk about cosmetics like mark or flashes. There's a cosmetic or aesthetics thing where the holding comes into picture. Till that, we'll be injecting the part without holding. And then comes the gate freezing analysis. Okay. So gate, if you talk about gate is the smallest area in our system, the mold. The first area to freeze or get to lock or metal get freezed is not a gate. So once the gate is freezed, metal will not go inside. If the gate is freezed and you are getting a lot of sing marks, some defect, then whatever pressure you apply from the backside of the machine, nothing will go inside. So it's ideal to understand what is the real gate freezing time. When we talk about raw material, also there are 2 types of raw material. One is amorphous like polycarbonate, ABS, then is semi-crystalline nylons and PPT and POM. So both the material behaves totally differently. Okay. To get the crystallinity, the semi-crystalline material nylons, to get this utmost mechanical properties, suppose POM, to get this dimension stability, we have to make it crystalline. Those are very crystalline, higher crystalline percentage of material. So that to make crystalline cell, we should have a higher amount of gate freezing time so that we are able to pack the part. So gate freezing study is one of the important study that gives a consistency. Then finally, the cooling time study. Cooling is money. So we cannot simply, and it's the optimum cooling. What is the optimum cooling required for the part or based on this raw material? So every raw material has its own heat distortion temperature, like HDT we used to call. So the heat distortion temperature is the temperature above which the material it has a deflection. It gets deflection. So ideally speaking, we should eject the part little lesser, like 10 degree or 15 degree below the HDT. That is the optimum cooling time. It doesn't require to cool the part. Suppose the HDT of polycarbonate is 120 degree. We can eject it 110 to 100 degree. No need to cool the part up to the 40 degree so that we can easily hold with the hand. No, that is not the thing. Nylons, 30% or glass fill nylons has a HDT of 150 to 160 degree. We can eject well in that temperature, 150, 140 degree. No need to keep it so much that we will not burn our hand. It's easy to hold the part. No, it is not required. Whereas Unfilled nylon can be operated 80-degree. ABS can be like 70, 75-degree. PP to 50, 40 to 50-degree. So different metal has its own HDT. So based on the HDT, we have to measure the part. When it comes out, what is the temperature, and based on that, the cooling time. There's a one step, one method of cooling time. There is a second method also for some critical parts. We can measure the dimension, some dimension. For measuring the dimension, we may have to wait 2 hours or day, right, to make it stable. So based on that, also cooling can be set. And cooling is not set based on the runner catching and screw bushes catching into the cavity. No, it should be based on the part. Whatever catching you have to attend the mold and solve. That is what science is. So to go with 6-step study, what is the pre-preparation, pre-request? What all the things we have to take care before going ahead? One is a raw material preparation. So every raw material has its own drying. If I talk about preparation, could be drying, pre-drying. Drying times are the temperature, cumulative. Some of the critical material have very close, lesser cumulative drying time. Not just drying time. Cumulative drying time means if you are repeatedly heating a material. Today I loaded a material or a mold and I ran it for half an hour. Suddenly mold breakdown. I took the mold out and again the material is collected back. Tomorrow I made the mold correct and again I am loading. Like that multiple times. Suppose you are doing. The material is if you add all the drying time, this cumulative drying time. If critical materials, if cumulative drying time, there's you'll be in misery. So those things also has to be taken. Then the melt preparation, what the melt temperature, and not only keeping the melt temperature, measuring them, whatever we are given in the machine, setting in the machine, thermocouple reading. So, it out and doing 80-20 principle with the copper pyrometer, we have to measure the temperature, what is as per the data sheet and as per the consistency. So measuring, preparation and measuring also very important. And then mold temperature. So every raw material, if you see in the data sheet, there will be, especially for critical specialty and engineering plastic, there will be mold temperature prescribed. It is not just to cool the part. Suppose a raw material is injected in 300-degree, we have to cool the mold temperature 120-degree. It's not just cooling the part or just easy to hold. It is for the molecular structure to align. The amorphous has a structure, semi-crystalline has a structure. The molecules are arranging properly and getting arranged as per its molecular structure. Then only we get the atmos property. So if you are overcooling a semi-crystalline metal, the crystallinity will not be able to meet. You will never get a dimension consistency, work-phase consistency, or mechanical properties, repeatability. So mold temperature is for that reason, not just for catching is happening, giving a cooling water here, empties here, all the things we are doing. That's not the right approach. Wherever the problem is that we had to attend the mold and correct it. It's not so complicated once you get depth of that. So that's why I told the creator is the real initiator of scientific injection molding, not the person who is just molding it. And short size, then we have to, before going, we have to set the short size as the decoupled method. It means injection, we have to inject a part 98% by injection speed or injection. Then after injection, there is a switchover point and we have to change or transfer into holding or packing. So this is known as decoupled, separating injection and holding. To do this, we have to first, how we can know what whether I am doing 98% injection. For that, we have to switch off the holding in the machine when we are taking the T0 trials. Switch off the holding and see what is happening in injection and make it the refilling and make the switchover point in the machine so that we are always injecting 95 to 98%. 98% the cavity is almost fully filled. Okay, and you can see some seam marks. If you are able to do that, then only you will be getting the consistency. If you are feeling only 50% and switching off, then what? There is tendency, there is a lot of variation. So always do to 95 to 98%. I personally 98%. Some of the critical parts, sometimes you have go to 95, but 95 to 98% is a good switchover. Then go to the holding 2% addition volume weight of the part. So this is how filling ends at 95 to 98%, and further then we have to switch over to holding and packing. And at the time of switchover, you'll get an injection time, actual injection time. The machine will show, all the closed loop machines will show. And second, there will be a peak pressure. These two things we have to note. This is what gives the study forward, takes the study forward. Okay, peak pressure, injection time. We'll be injecting the part in a certain speed. Suppose I'm refilling 50 mm. My switchover is for 10 mm. From 50 to 10 mm, I'll be injecting in a speed. That time cavity, nothing will be the roll air will be the moment the cavity start filling, it's reaching about 98. Suddenly the pressure rises in the cavity because it is going to fill. That pressure will exert pressure on the screw, and the pressure, the transducer will measure that, and it is shown on the, that is known as the peak pressure. That is very important for understanding the doing viscosity study. Okay, then after all these things, all this study, viscosity study, cavity balancing, pressure drop, then only we have to go for giving the holding. Till that, holding has to be kept 0. So this is the step. First is a viscosity study. Okay. Just a second. So in viscosity study, what we are doing, you can see I am taking samples. Like I will start from a lower injection speed. The machine can be, when we are, suppose you are traveling from Mysore to Bangalore by your car. You can go in 30, different 50 speed, 70 speed, 80, whatever speed you wish, you can go in those speeds. Okay, and the time when you reach is an output. You are not fixing a time and going as per the speed, will not be like control. You will go in some speed and the time is the output. Similar way in injection molding, when this will be done at the time of T0 trial. That's why T0 trial is very important. It's not just measuring the part or looking just whether an aesthetic is correct or just the features are there. T0 trial is a trial for setting the process. Process means injection speed. Then based on injection speed, we'll get the output, the filling time. Based on, see, I started with the 30 injection speed, okay, slower injection speed. The filling time I got, machine will show, or the machine show what is the actual filling time based on the resistance of the metal machine, the screw bush, runner, on the part. There will be a filling time coming on the actual. So that we had to note down in this spreadsheet. Then with respect to that speed, what is the pressure? That peak pressure when it is filling 90, that machine will show that. We have to just write it down. The viscosity will be automatically calculated. Okay, there is a background calculation going around, but from this we'll get a viscosity. Then after 30, we have to make it 35, increase the speed, and again we'll put the filling time and peak pressure, whatever we are getting. Then after 35, go for 40, like go for increment of 5, 40, 45, 50. So against each injection speed, whatever time I'm getting, actual filling time, actual peak pressure I'm getting, I'll be putting across, and the viscosity will be calculated based on this viscosity. Beautiful chart, no? You can see this right side. Viscosity related in respect to injection speed. So with respect to different injection speed, you can see the viscosity keeping on changing. And the beauty is that, see, this here you can see different from 30, 35, all this, every differential injection speed, there is a change in the viscosity. But after 70, you can see it has become flat. So this flat area is the Newtonian area. Any change in the raw metal, minor change in the raw metal MFI, which affect the viscosity. Any change in the atmosphere, which affect the viscosity. But this is the area, beautiful spot for any such natural variation. Our metal, the filling pattern, the way it fills remains the same, because this is a Newtonian area. So this is what first we have to find out, and we have to keep somewhere. Most of the people prefer to keep in the bending area, but personally, if you are very good holding tooling, you know how to correct the thing. If you have the holding, if you know what is the reason, I personally tell you can shift little more head and keep it, or get the utmost consistency in terms of dimension. Okay. So if you are operating in this area, sliding area, where it's non-Newtonian polymer, if every change in the shear, the raw metal property is changing or viscosity changing, forget about consistency. So this is the sweet spot we have to identify for viscosity studies, to identify where is in my metal, what speed. So we got the best injection speed for injecting that part with that mold, with that raw metal, and that machine. This is what we had to identify. And with this speed, we'll be going ahead. But of course, when the speed is higher, The higher the speed, there may be some air impairment and all that, shear mark in the gate that you have to do with the tooling knowledge. There is shear rate calculation is the air venting things are the principles, and with that, if you are able to, then you will get a fantastic viscosity and consistency. Okay. Then second is the cavity balancing. In cavity balancing, we without holding, here we will be understanding different cavities. We will be measuring the cavity, taking out the each shot, like 10 shots or 20 shots we'll taking and measuring the 3-digit decimal milligram type of weight balance. Understand? So generally, without giving holding, if your part is getting within 5% weight, then it means when you are giving holding, you will get a very good repeatability in the cavity. It's a 98% of the part switch over, you are getting a 5%. This analysis is done to understand that 5 is a good thing. But suppose it's a bigger part and all, you can go for 8 to 10%. Also very quite like automotive type of. But small critical parts, we are talking of consistency and criticality, then we have to talk about 5%. And some people does in 50% filling also. Part will be filled only 50%. It can be like 15% difference also is acceptable. Okay. Then if you are able to meet this, so cavity to cavity consistency comes only if the steel is machined same. If the feed systems are all the cavity are behaving the same, the filling pattern all cavity are same, the cooling of the all the cavity, the bending of the all cavity. So we have, if we are not getting any balance, we have to check one possibility why it is so. Okay, this is how it will be done, and that also calls for cooling correction. And the third thing is that pressure drop study. So here what we will be doing. So we know, see, when the metal is being, molten metal is being injected inside the cavity to the part, the metal goes to first, the pressure drop happens, the machine knows it. Okay. Second, it happens the screw bush. Third, if there is a primary runner, secondary runner like that. Runner, if there are multiple runners, a primary runner, then secondary runner, there will be some pressure drop. Then the one of the major areas, the gate area, there will be a pressure drop. And then after gate and the cold part is there. So this is how the pressure drop happens in the system. So we should know what is the real. There is, we can do, there is a study in the machine. That's why if you tell first time right, there is nothing called as first time right, because the pressure drop can be only done when the mold is loaded in the machine, because the resistance of the machine, the resistance to flow in the mold, the gate, the real cavity and all, we can only know when the mold is in the machine. So first time right, in case molds, for me it's like it never happens. Every time there will be some modification. If you have done a mold and you have copied it exactly and your old mold was having all the consistency and all, there's a different case. But otherwise, there is nothing called first time right as per me in the molding industry. Yeah, you can make it second time right, not first time right. So here we will be measuring the pressures in the machine. You can do a different switchovers and fill the part up to the gate, up to the runner, up to the nozzle, and in the end is the 98%. And you have to put the pressures in this, whatever is pressure, the machine will show what is the peak pressure. And see, if you are getting a, see, the thumb rule says like for a cold runner, for a normal mold, if you want a consistency and to fill the part up to the end, 98%, if you are getting 70 to 100 MPa, means 700 to 1000 bars. For a critical part, I mean to say, not for a cable tie or a commodity parts, I'm telling. If you are able to fill in a 70 to 100 MPa, means 700 to 1000 bar, then you will get a repeatable. If you are taking so much pressure, they forget about consistency. So here we are studying whether it is within that, first of all. Second thing is that if the allowed thumb rule is like cold runner, if you are able to last 30 to 35 MPa, that is good enough. If hot runner, yeah, it is more restrictive. So 40 to 45 MPa. If you are able to feed system, pressure drop within 30 to 35 for cold runner, hot runner 40 to 45, then rest our part will come. Suppose our feed system gate or feed system is taking so much pressure, like 100 MPa, then what our part will not get anything. Only the runners will look very good, shiny. That's not a thing. Our part should get the proper pressure. So we have to. It's not like a pressure. Let the part get all the pressure. I give the runner. So no, it never happens. The raw material has a shear thinning, shear behavior also. Oversized runner also is a problem. So runner is always optimum. Okay, few systems. So we have to understand where is the pressure drop happening. Suppose the pressure drop is happening in the gate. Correcting the runner screw bush, always we tell the tool makers like gate, if I increase the gate, I cannot reduce, so I will not touch. So when we will touch the gate? If the pressure drop is happening in the gate, we have to correct gate only. If we correct the screw bush runner, nothing is going to happen. And if the pressure drop is happening in the screw bush, correcting the gate will not give any result. So understanding where the pressure drop is happening can be done with this study. If suppose my up to my gate only 35 MPa, 350 bar is the pressure drop. Total filling the part it is 160 MPa. However you increase the gate, nothing is going to happen because the pressure is taken by the part. That's the problem of the part. The part thickness is lesser. The MFI of the metal is lesser. It's not simply increasing gate. So where is the pressure drop happening? If the part is taking excessive pressure, it's a problem of the part. Sometimes what happens, we keep on correcting the gate. It may take 1 month, 2 months of R&D. Finally, we know that it's not getting filled. The machine is injecting and some sound is coming from the machine. All this machine. There is later we'll tell the customer that, oh, this is the part problem. Why need to wait for that? You don't have to wait for that because this can be done at the T0 trial itself. This is how the pressure drop study has to be done, and where the pressure drop is, and there we have to correct it. That's all. The fourth, till that we'll keeping the holding 0 as a decoupled molding injection and holding as a separate. Sometimes I used to see like when I go and check some of them, like keep the holding 0, the machine what is running, suddenly the part become like 50% fill. That's not right. You want a consistent fill 98%, 95 to 90% by injection only. You remove holding also, part will be like looking some sing mark will be. That's the right condition. No need to wait always. Then till that we'll keep the holding 0. Now is the cosmetics. So those are the processing, deriving the, see, processing means the real understanding the viscosity in Newtonian area. That is the real injection speed is the key. Then after that we will start holding. In cosmetic window means we will do the holding. We'll do this DOE in 2 steps. First with the lower melt temperature. Lower melt temperature, I'll keep on reducing the holding pressure. And if you keep on reducing holding pressure, there will be unacceptable limit where my part will look sing mark. So that is one. So I'll note it down. Then I keep on increasing the holding pressure. I will keep increasing the same temperature, melt temperature. After some time, what happened? I get a good part, then I'll get a flash. So 2 extreme condition of cosmetic. One is a flash. Second, lower end is the sing mark. So with lower temperature of the polymer, because polymer people tell no, suppose 230 to 250, 250 to 280, 290. Like there will be a range. So I'll start with the lower range, then I'll go to the and lower range. I'll find out the holding pressure where it gives a flash, lower and where it is a sing mark. Similar way, I'll put the higher temperature of the polymer to scale, and again I'll do this. I'll understand where my part is getting sing mark, and next increasing the pressure where I'm getting the flash. So with that, there will be, you can see this window is been made from this data, and the center of the window we can start apply the holding and start the go ahead forward. So this is optimum. So any minor change in the polymer or something happens, still we will get a acceptable. There is a big window where this window is the area all our parts are acceptable. So if we talk with how the polymer behaves a PVT pressure, viscosity and temperature. Okay, and whatever minor changes, still our part will be accepted. This is a box where so we are identify which is the window where holding window where we are getting acceptable limit, and while running the part we'll keep it in the center area and proceed. Okay, this is what cosmetic window is. And then after cosmetic window, it's a gate freezing study. As I told, gate is the first area to freeze in a mold. Suppose the gate is freezed. See, everybody knows that plastic, when it flows, it flows. The moment it stops, plastic is not like water or oil. The moment it stops the flow, it freezes off. Then how much pressure you apply from the backside, nothing will go inside. So gate is the area which freezing happens first. It's the name itself is gate. When the gate is getting closed, means we cannot go in the similar way. The gate is closed in the mold, polymer cannot go inside. So here what we'll start with single 1 second of holding time, and we'll measure the part weight in the 3D zone. Then after that, after some time, we'll make it 2 seconds. Then we'll measure the part weight. Then 3 seconds. It has to be done on part weight because the gate freezing time. Since we have done the cavity balancing study, we know all our cavity behave the same way. So this has to be done in only one cavity. No need of picking all the cavity because we have done that earlier itself. Okay. Once we get into this, we have first study, second study, third study already over. We don't have to go back. So the moment suppose the cavity balancing is not happening, then we have to correct the mold and bring all the cavity balance, then again load the and again start from the beginning of the moment you correct the gate something, what happens, viscosity change. So again we have to start from the beginning. So like that we have reached this stage. Okay, it is not like we directly put all the studies and finish and with that Excel sheet we'll visit. No, if one is not answering, we have to correct. Okay, if one is answering, then only we can go. That is answering, then we can go for the third step. Third is not answering, we cannot go for four. No need to go for four. Stop there, understand it, correct it, and come back. Okay, that's all. So with 1 second of packing holding time, what is the weight? Second, if I give 2 seconds, obviously the weight will increase. So I will give 3 seconds, 4 seconds. I keep on increasing 1 second and 0.5, depend on the part to part. Then you can see after some, you can see a flat area here. After 7 seconds, the weight is 3.09, 8 seconds 3.109, 13.10, 10 also 13.10, and here the weight is not getting affected by increasing the holding time. It means my gate is freezed. Suppose in that freezing time I am getting a sink mark, that means I need to work on the gate. I need to improve the gate freezing. How to improve the gate freezing time? First, the modifying the gate size. Second, it could be gate shape also. Okay, so this is how gate says we have to divide at the time of gate freezing time. And once we are corrected, again we have to start from the beginning. Okay, and see, I was telling for a nylon, some people are telling the dimension is not coming, or palm, like Derlin palm dimension sometimes bigger. And this is only because we are not because those metal are semi-crystalline, has to be packed and made crystalline. Our gate freezing time is so lesser, we are not able to pack it. That's the reason it's not getting stability. So if you work on gate freezing time for such project, you'll be able to get that consistency. Otherwise, the part dimension keep on changing time to time. Okay, so this is very important. Then is the cooling time study. Cooling time, as I told, cooling is the 60% of the cycle time. So yeah, money. Yeah, if you want to save something, more saving than cooling. Not just adjusting the cooling time in the machine. Mold should take care. It means there should be enough cooling lines in the machine, okay, in the mold. Okay, looping should not be there. Mold is a thermal system, and proper thermal conduction is there. If I tell you, there is no upper limit to the cooling lines. So here what we are doing, we are starting with the always optimization. We wish to reduce the cooling time. So we start with the higher cooling, suppose 20 seconds. We start with suppose this is a raw material which HDT, heat dissolution, is a polycarbonate. Heat dissolution temperature is 120 degree. Means I can eject the part out below 120. There will not be any deflection. That is good enough. Maybe 110 and 100. So here what we are doing, I put at 20 seconds, then 90 seconds, keep on reducing the cooling time. And each cooling time we are putting what is the measured temperature using infrared pyrometer. You can measure the temperature and put it. Touch probe we are using here. The problem is that by that time it cools down part. So the part that is coming out we have to measure. Suppose here 20 second 80 degrees coming, 19 second 90 is coming, 18 second 110. See all are below its SO. All this cooling time are okay. But the moment it reaches 17. The temperature has gone to 120, which is close or same as HDT or higher than HDT. It is not acceptable. So here, optimum cooling time, we can take something 18 or something and go ahead. Okay, this is how optimization in cooling time can be done. Not just some thumb rolls or something. And it's mold combination, mold, your material, all these things affect the cooling lines, channels, the insulation sheets, everything the shear rate of the raw material in the feed system and the part, everything gives rise to cooling time. Okay, not just some thumb rule will not really function. Okay, so those are the things. 6-step study. So viscosity study, cavity balancing, pressure drop study, then cosmetic window, then gate freezing and cooling time study. These all 6 things are put together on a 6-step study, scientific injection molding or decoupled molding. Okay, if we are able to do this at the time of qualification and qualify all these things are answering, then that mold will have most consistency, and the mold, without any interface, without any modifications of parameters, it can be easily run. So that is what thing is. And mold qualification in the same way means first, never check. It's not the part came out and you are so happy and you're given to all the people, customer also is so happy. You started measuring the dimension and you corrected something. Later on, you're not able to get the dimension again back. Sometimes you have to throw away the steel and the project also goes out of. No. First is the deriving the molding process, means the viscosity, the speed, then where is the Newtonian area. That's the first step. Okay. Newtonian area, then your pressure drop study and cavity. If you have done these 3 things are the process, then only go for cosmetic. The problem is that we always look for cosmetic, part is filling. That's all. The moment the part is filled, we are happy. We feel our 195% job is no. If you want to get the concept, part filling or not is never a matter. Part is not filled, everybody do something, modify the gate and all. That's a very layman thing. If part is not filling, adjusting the, nobody has to tell. This is a very common thing. Even the part is filling, still understanding the pressure drop, still understanding the Newtonian area, then cavity balancing. That is the science actually. Otherwise, it's just simply any layman can do. So understanding that and then go for cosmetic looks. Air venting, there is an air entrapment happening or burning, is go for an air venting, not reduce the injection speed. The moment you reduce the injection speed, consistency go for a toss. You are operating non-Newtonian area where you will not get a consistency by impact. So we cannot get that aesthetics by compromising the injection, something speed and all, because we need consistency. We have to operate Newtonian area. There is no other way. Okay, that's the reason we are not able to critical parts in our ecosystem. Then third is like design of, you can go for cooling, DOEs, cooling optimization, holding, so mold temperature, all these things is the third thing. And dimension measurement should be done after that only, not at the beginning stage. If you're doing the dimension at the initial phase and you're correcting the gate sometime, what happens? All things will alter. Your viscosity will alter. Indirectly will not be knowing. Thing is the viscosity has gone for a toss. The minor correction in the gate itself is change the viscosity. And if you corrected the steel, you lost the steel, then gone case, you have to throw the cavity out in terms of critical parts. Okay, in terms of fit and forms, this is a different story, but we are talking about critical parts and it's typically. Okay, so what are the prerequisites? See, just getting this spreadsheet is good enough. Can you do the same? No, that's the area where everybody is stuck. What knowledge we should have? We should have a detailed knowledge of plastic raw material behavior. I think that's one of the things which is not so much percolated in that. See, the raw material behavior, how it flows, what is the shear rate, the fountain flow behavior, all this polymer behavior wise, we should know what is shear rate. Different raw material has different shear rate. Based on that, the feed system changes. So based on the flow changes. So these things has to be done. Then material selection and data sheet. How really we can interpret the data? See, looking this polymer, just seeing the polymer. Oh, yeah, I done this. Every grade, there is a specific reason to develop a grade. The higher the grade, the costly grade, or higher the property of the grade, always is very sensitive. We have to take care. If you are not able to take care of that molecular, there will be destruction of the molecule and will not get the property. So the costly material is like costly, I will tell, is a stray dog and a costly imported dog. Stray dog, you don't have to do anything. It will take care. The moment you are buying a costly dog, you have to take care a lot. Otherwise, it will die easily. Similar way, the costly materials, like we have to take care. Otherwise, we will not get any property out of that. We will destroy the property. So that thing has to be understand. Then third is the raw material preparation. How to prepare the raw material, the pre-drying things of the raw material, the cumulative drying time. Not only just drying time, even the cumulative drying time. What happens? Some of the cases on morning the part will be running nice. After some time, then it starts sticking. Some sound of the ejector will start coming, and some lubrication might have escaped. So, what is the dryer capacity required for drying these things? All raw material preparation, storing, transporting, everything should be known very detailed. Drying also. And then process establishment. Process establishment in the sense is not just simply adjusting and looking the part. Okay, no, is a 98% filling and then going to holding that. Establishing that 98% switchover, establishing the refilling and switchover ideally to make it 98% is very key. Okay, and mold design, we should have a knowledge on mold design, especially feed system and cooling. Feed system is very important, not just for filling. The thing is that we never touches the feed system if we are able to get the part, fill the part. The moment filling, yes, we fill, yes, it is done. No, filling is not just the key. Filling is only one aspect. If filling you are doing with a very high pressure, forget about consistency. If you are just filling by increasing the temperature, forget about consistency. Your raw material itself you are damaging. So filling with the stipulated thing requires the adjustment of the system. Always, if I tell 1000 moles, if I made in 995 moles, I corrected the feed system. Otherwise, no. So that I mean to say there is no first time right really feed system. And cooling, of course, cooling, very good cooling. And cooling is a never-ending thing. Feed system cooling is a never-ending, and your cooling and even our air venting is a continuous case and continuous improvement. There is no end to that. Okay, and root cause and troubleshooting instead of just trial and error, real root cause what is that and how to troubleshoot that. It should be, and it is from the product and the mold. Okay, it's not just by processing mold. And the product design knowledge, the thumb rules, which raw material can achieve this dimension. Not all the time raw material behave the same way. Sometimes, like some of the raw material name itself, one is amorphous, semi-crystal, both behaves the totally different way. So which raw material, what dimension can be achieved, what filler can achieve what dimension. There are a lot of studies into that. And with respect, see, we cannot achieve what raw material is not capable of achieving. First of all, understand. If you want to achieve that, we have to select those raw material which capable. Otherwise, we have to in advance do a risk analysis. Advance we have to tell the customer, okay, this part is going to have this risk on dimension we are not achieving. So the problem is that we accept everything at the time of order and we'll tell, yeah. Then we started blaming customer, tell no, it's not. After we take multiple try, we put all our hard works, okay, and later on we'll tell, so this is the problem. See, do we have to do every time this time-consuming research work? No, it's not required when we are doing this work. So if we are adhering to product design, we initially itself we can do a very good DOE and we can tell reasons. So they also knows what is the risk, and based on either product design or they can accept at the initial stages. Later still getting, accepting, fighting, nothing is going to happen. Please understand. Okay, everybody is losing. The industry itself is losing. Then the predictive analysis. Okay, predictive analysis in rheology, the mold flow, many are doing mold flow. The problem is that mold flow we are doing, but real mold flow report interpretation is the key. And we seeing, I've taken training in the company, and the mold flow person is saying, I used to give mold flow for all the mold in very detail. It's very serious person. So the thing is that the other side, the designer person got up and told, no, have your mold flow anytime matched. You're giving it, but it's not useful. Then why we need to use it? That's the condition. So mold flow real running interpretation based on raw material, interpretation based on there are a lot of hidden things in the mold flow report. Beautiful it is. If you're able to interpret that hidden things, whatever we are writing at the end of the thing, nothing will be there. See, if well line is coming, well line is coming. Air entrapment, air entrapment. Whatever is shown, we are writing. It's not an interpretation that any layman can. But there are whatever hidden things. The shear rate is the rate, and what the shear rate will cause to the part. Stress in the part can be identified. The hesitation in the part can be identified. Sometimes the tonnage itself gone totally wrong. Somebody's recommend this part cannot be run in this machine. You have to run in instead of 200, 500 ton machine. Such type of things. So Moldflow is really a good tool if you are able to interpret. Don't just take that red color, green color scale and tell her red came problem. If you are able to interpret that is good to really have a successful scientific injection molder. And obviously machine auxiliary equipment size, the size of the machine, calculate the size of the hopper dryer. So all the auxiliary equipments, we should be able to know what is exact size required. But when we are operating, obviously when we are calling a critical dimension, the raw material will also be critical. So here auxiliary equipment selection plays a very important the sizing. Okay. To end this, consistency can only be achieved when the creator knows the molding process. Creator means the designer or the tool maker knows, and we can identify the root cause. Not is somebody's job, really speaking. But I am not telling you should master the molding machine operation. No, you have to just see, just ask him what is the peak pressure coming, what is injection time coming. Then automatically viscosity is done. That's all. We don't have to operate everything. Nobody need to operate. We just want to capture that and put it in the graph. And just then we have to just see where the pressure drop. Put in this graph. That's all is required. No need to operate. The biggest problem it is like people when we talk about injection molding, scientific people think it's a molder's job. I think we don't. Tool makers tell we don't know how to operate a machine. So I cannot be an injection scientific engineer. No need to operate. Just take out the reading, put in this graph. That's all. And second is mastering this approach paves the way for excellence in every mold and product we create. That's all. Okay. With that, thanks everyone for attending. See the vision of my vision. See, since if we want to India to be a critical mold manufacturing export hub, there is no other way. We have to know the science of injection molding, and this is a science of injection molding. Okay, you can go for this study on this from anywhere. I'm not just thinking. I alone I cannot reach this to nook and corner of India, but I wish to, but it's not possible. So you can go anywhere and start exploring about this and go towards an scientific injection molding. Then only we can make it. Our industry can go to that level. So with that note, I'll end my presentation. And if anybody wish to connect with me, you can very well connect with me in this number. And if you wish to connect with me in LinkedIn, I'm available. You can connect. Wish everyone all the best, and hope the vision of making scientific injection molding and making the critical parts in India. All of us are for that only, and to make our life easy as injection molders, tool makers succeed. All the best. Thanks everyone for that. Okay, thanks.